So now let's find the point of intersection using this technique called substitution. When we have two lines, what we want to do is we want to isolate one variable and substitute that result into another equation. So this is the same problem as before, but let's just try it this way. I see variable x is all by itself, so I'm going to solve for x. It doesn't really matter whether we choose x or y. So what I have here is x is equals to, I'm going to move the 2y over, negative 2y plus 3. So we know what x is. This here is the value of x, negative 2y plus 3. What about the second equation? Because we know what x is, x happens to be negative 2y plus 3, we can actually take this result and plug it into x. So for these two different lines, by forcing the x values, this here is x for the first line, this here is the x for the second line. By forcing the two x's to be the same, by plugging this into here, we're actually finding the x value of the point of intersection, because there at the point of intersection we have the same x values. That's kind of a deep concept which you should think about. So for now, we're going to just take this x value, plug it into the second equation, and see what happens. Y minus 3 times x, which happens to be this, negative 2y plus 3, is equals to 1. We're combining the intelligences of these two equations. So we just work it out using algebra. We distribute this times this, this times this. Negative times a negative is positive. 3 times 2y is 6y. Negative 3 times positive 3 is negative 9, is equals to 1. So what we can say here is that y plus 6y is 7y, because it's like 1y, is equals to 1 plus 9, the negative 9 becomes a plus 9, so which is 1 plus 9 is 10. So we're going to divide both sides by 7, we get y is equals to 10 over 7. This here happens to be the same result as we got in the last video. Once we know that y is equals to 10 over 7, we plug this result into either equation to find the x value. Let's just choose equation number 2. So thinking about equation number 2, let's just change this color here. Recall that y minus 3x equals 1. It doesn't really matter which one we choose. I'll just say choose either equation. So what we have is, we're choosing equation 2. We know what y is. I'm going to plug in y here. 10 over 7 minus 3x equals 1. We can move the 1 this way, which becomes a negative 1. And we can move the negative 3x to the right, which becomes a positive 3x. Let me just move this equal sign a bit lower. We could change the 1 to a 7 over 7. And so 3x is equals to 10 minus 7 is 3 over 7. And so we're going to divide both sides by 3. I'm going to say x is equals to, so let me just flip this around for you. 3x is equals to 3 over 7. And let's just continue off up here. I'm going to divide both sides by 3. So we get x is equals to 3 over 7 divided by 3, which is the same thing as 3 over 1. So x is equals to 3 over 7 times, and we always flip it, the reciprocal is 1/3. So x, the 3's cancel out. You're allowed to simplify diagonally, 1, 1 when we're multiplying. And so finally, x is equals to 1 over 7. So the point of intersection happens to be here and here. Putting the two results together, we have the point 1 over 7 comma 10 over 7, which is the same as what we had before. So in this problem, we began by isolating the x, which we then used this result and plugged it into the other equation. Now let's try it in terms of isolating y. It doesn't really matter which one we isolate, but as long as you find out the value of one variable and you plug it into another equation. Let's try it again now. So we're still using this technique called substitution, but in this case, let's isolate y. Y is equals to 3x plus 1. We moved this negative 3 over here and ended up becoming a positive 3, and the 1 stays the same. So we know what y is. This is the value of y. And we're going to take this intelligence and we're going to stick it right over here into equation number 1. So focusing on equation number 1, we have 2y plus x equals 3. This y value, recall, is 3x plus 1 plus x equals 3. And using distribution, 2 times 3x is 6x, 2 times 1 is positive 2, plus x equals 3. 6x plus x is 7x, and here the 3 minus 2, this positive 2 becomes a minus 2, becomes 1. So x here is also the same as before, 1 over 7. We're dividing both sides by 7, so 1/7 is the x value. You can see that we're getting the same result. So last time I plugged in the x value into the bottom equation, let's plug it into the top equation just to be different. So recall equation number 1 is 2y plus x equals 3. I'm going to plug this value in here to find y. 2y plus x, which happens to be 1 over 7th, equals 3. 2y equals 3 minus 1/7, or if you really want, you can even multiply everything by 7. When we multiply everything by 7, each term by 7, we eliminate the denominators. So let's try that. So by multiplying by 7, we get 14y plus 1, the 7 and the 7 cancel out, equals 3 times 7 is 21. So 14y equals 21 minus 1 is 20. Continuing up here, divide both sides by 14, and we get y equals 20 over 14. And you can divide top and bottom by 2, we get 10 over 7. So this here is the same result as before. We have an x value and a y value. You can see that it doesn't really matter how we do it, just choose your favorite way. Algebra is algebra, and the result is exact. We love this method called substitution.